All right, friends, we had a few questions come in over the weekend, so I'm going to do those, and then we're going to do the lesson. So we're going to start with this from 2.2, then we're going to do the lesson. If you want me to, if you don't need help with this, just skip over it and go to 2.3. I'm going to 10a. This is page 102. Write the values of the variable for which each radical is defined, and then simplify the radical if possible. Okay, so we have the cube root of negative 8x squared. Negative 8, remember 8 is 2 times 4, which is 2 times 2. So 8 is 2 cubed. We have a negative 8 here. We make each of these negatives, that works. So we can pull out the negative 2. The x squared is not going anywhere, unfortunately, because of that cube root. If it had a 3, you can take the x out. But you don't, so you can't. So it's negative 2 cube root x squared. It's kind of like if, so like this is the cube root, if say this was 6, 6 is 2 times 3. Or if it was 4, that's 2 squared. You can't take the 8 out because it doesn't have enough kind of whole number factors. Similar idea here. Cubed or higher, we could simplify, but we can't. B, 48b to the 4. And this is all under the root sign, so I can tell you right away, I don't know the factors for 48, but the square root of b to the 4 is b squared. So for sure, b squared is coming out. And there's not going to be any b's left inside, because b to the 2 times b to the 2 is b to the 4. Now we just got to figure out 48. And this is just the square root, yeah. So 48, 2 times 24, 2 times 12, 2 times 6, 2 times 3. Now we take out all the pairs we can. 1 pair, 2 pairs. 2 times 2 is 4. 3 is left on the inside. The root of 4 is 2. The root of 4 is 2. Or you can just multiply these numbers. That might even help better. 2 times 2 is 4, times 2 is 8, times 2 is 16. The root of 16 is 4. So just pop that bad boy out. The root of b to the 4 is b squared. Okay, for b and d. Fourth root. Well, it looks like 125, I think, is 5 cubed, so I don't think that's going to go anywhere. Oh, this whole thing might not go anywhere. Oh, I'm also supposed to write the values of the variable for which each radical is defined. I'll do that in a second. 25 is 5 cubed. So 5 times 5 is 25, times 5 is 125. So we can't pull that out because it's not high enough power, similar to what we were talking about with our 48 here. This was high enough. Same with 8. That was high enough. Any lower, we're stuck. We're stuck here. Same with x cubed. This one doesn't change. Okay. Just gonna have a quick peek at the answers before I talk about the impermissibles. 10a. Just make sure I don't make any mistakes. Negative 2. Yep. B. 10b. And D. Yeah. Okay. So now what can x or b, what can they equal, what can they not equal? In this case, x squared, it can equal anything. Because when it squares itself, if it was negative 1, it's going to equal positive 1. And that works for underneath the root sign. Over here, again, it's even. Same idea. X can be anything, or b can be anything. So here, x is an element of reals. Here, x is an element of reals. It's even numbered. It can be anything. Over here, it's odd inside, excuse me, inside of an even root. So x has to be greater than or equal to 0. Because the negatives won't cancel out. If that was negative, we got negative 1 times negative 1 times negative 1. That equals negative 1. There is no solution for negative root 125. Negative 4th root 125. oops, sorry, I wrote that stuff right there. X has to be greater than or equal to 0. Can't be negative. If it's negative, then when the power is done, it's still negative. Negative underneath an even root sign, you're in trouble. Okay? Hopefully that helps. Notes. A little bit of bad news for you note-wise today. Let's take it down first. All right, now that you've taken it down, this isn't all that difficult. It just takes a little bit of time. It's factoring. It's factoring underneath the root sign, simplifying, and then collecting like terms. That's everything. Now, the bad news, check understanding, we're going to do these. We're going to do these because there's like 3 parts to each one. And I think if we do that much practice over here, I'm doing half your assignment for you. You're not learning anything. We're going to do the check your understandings. I'll take one of these assignment when I can, but I think today is worthwhile. So, here's my paper clip. And note, did that. And now, check your understandings from 2.3. Okay, number 1, simplified. Number 1 is just showing us the beginning of it, kind of a thing. This is the walking before you crawl a little bit. Not good. I'll focus once I get writing on there. CYU numero uno, page 111. So the first one, 9 root 5 minus 5 root 5. So this is all about collecting like terms. Okay? You have to treat the radical as like terms. Kind of like if I cannot combine x plus x squared or plus xy or plus xy squared, none of these are common. Same idea, like the root of 5 plus the cube root of 5 plus the root of 5a or whatever. None of these are common. The entire radical, not including the number in front, like 5 root 5 is fine. Okay, that's like 5x plus 6x. I can combine the 5x and the 6x. In this case, it's the entire radical that needs to be the same. These bad boys are identical, right? Like you got to look at this part. So they're identical. 9 minus 5 is 4. That's it for that one. For B, there's some writing here. Cube root of 24 minus the cube root of 192 minus the cube root of 192 minus the cube root of 375 minus cube root of 375. Okay, this is really close. Anyways, ignore it. Okay, so we got to simplify each of these and figure out if we can combine these terms or not. 24, 2 times 12, 2 times 6, 2 times 3. So cube root of 24, we're going to take out a 2. Oh, it's cube root, sorry. It's a group of 3. Take out a 2, because 2 times 2 is 4, times 2 is 8. The cube root of 8 is 2. So this is 2 cube root 3, because that's what's left over. Okay, minus, I don't know I'm going to be able to fit all these in like this, but I'm trying. All right, kind of small. 292 is 2 times 96. Is that right? 180, 192. Yeah, 2 times 96, which is 2 times 48. Just 2 times 24. 2 times 12. 2 times 6. 2 times 3. So each group of 3. 1, There's 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. The cube root of 64 is 4. 4 cube root 3 is left behind. Does that make sense? So 4 cubed, 4 times 4 is 16, times 4 is 64, 64 times 3 is 192. 375, I'm just going to start a little higher because I have a feeling it's going to take longer. Could be wrong. 5 goes into that. How many times? 5 goes into 75, 15 times, goes into 360. Is it 67? Let's just make sure. 5 times 67 is 335. It's wrong. 375 divided by 5 is 75. That felt too easy. 5 times 15. Is that right? Yeah. 5 times 3. So there's a group of 3, and hunky-dory, we are left with a 3 inside the cube root. So we have 3 like terms here. We can add these up. Notice you won't always get that. It's like you could be doing like 4 questions. Oh, good. Oh, good. Oh, good. What? Doesn't mean you did something wrong. It might, but not by definition. Okay, not all questions are going to work out super lovely. 2 minus 4 is negative 2. Negative 2 minus 5, negative 7. These are exactly the same. Cube root 3, cube root 3, cube root 3. If there's an a in there, or a square root 3, or a sixth root 3, or whatever, it's different. Negative 7, cube root 3. All right. Next one. Root of 63. I'm feeling this one's going to mess it up a bit on us. Plus 40. I'm going to put some space here to see if I can. Oops, 40. It's root of 40. Put some space here to see if I can kind of work down from it. Minus root 90. Minus root 28. Okay, this shouldn't be too hairy. 63. 7 times 9. 9 is 3 times 3. So 63. 3 root 7. 40. 2 times 20. 20 is 2 times 10. 10 is 2 times 5. Square roots, we can only take out pairs. So it's taking out the 4, leaving the 10 inside. 4 root 10. Or not 4, I'm sorry, 2. 2. I was just thinking that's way too big. 2 times 2 is 4. Bring it inside. 4 times 10 is 40. Minus 93 times 30. 3 times 10. 2 times 5. That 10 staying inside. 3 is coming out. 3 root 10. Like terms, I have a feeling it's going to be a root of 7. 2 times 14. 2 times 7. Yeah, it's 2 root 7. 3 root 7 minus 2 root 7 is root 7. It's not, you can put a 1 there. Definitely not 0. If it was 3 minus 3, that's a 0. That cancels. 1 root 7 is the same as root 7. 2 minus 3, negative 1, root 10. You don't need the 1, but you can. It's kind of like x equals 1x. Should probably check my answers. Did I check the other ones? Oh yeah, took me a minute to find it. Okay, so let's check your understanding number 1. I think that's relatively straightforward. Okay, let's go to number 2. CYU number 2, page 112. Okay, it says identify the values of the variables for which each radical is defined and then simplify. So our first one here says 6 root a Nope, it's not a comma. 6 root a plus 5 root a minus 11 root a. A has to be greater than or equal to 0. If it's negative, you got the root of a negative sign. You've got an imaginary number. It's by itself in there. Nothing is changing it, affecting it. It's not squared or cubed or nothing. So it's got to be greater than or equal to 0. 6 and 5 is 11. Like these are all the same like terms, right? Just root of a, root of a, root of a. 6 plus 5 is 11. 11 minus 11 is 0. So your final answer is 0. It's not 0 root a. It's just 0. This could be a step, but that's final answer. You know, it's like if you're asked, how much homework did you do over the weekend? And if it was 0, you say 0. You don't say, oh, 0 times, oh, it's 6 hours. It's 0. B. These are getting fun. God, no, I need to find a different way to set up my system over here. Does this work? See it better? Oh, yeah, no, that's right. Thought I was doing the wrong question. Okay, so root 50 a squared b minus 8 a squared b. Okay, so a is an element of reals because it's squared. These are even roots, and the a squared, you put a positive or a negative or a 0, everything's fine. Doesn't make it imaginary underneath there. So a is an element of reals. B, however, needs to be positive. Because if it's a negative, it would be the only negative underneath here. And it would make it negative and it would wreck it. So you can't. 50, maybe I'll do the work over here. 50, 2 times 25, 5 times 5. So that means 5 root 2, that's 50. Pair of 5s comes out. For 8, we should, well, I shouldn't say we should. I should. Remember, it's 2 root 2. 8 is 2 times 4. 2 times 2. Take out a pair. 2 root 2. That's 8. So these simplified. 50 became 5 root 2, but I can bring out an a, because the root of a squared is a. 5a, and then that b, poor b, sits in there by itself. Oops, and the 2. It's not alone. It's got the 2. Okay, because 50 is 5 root 2, and then the root of a squared b is a root b. 2a root 2b. Right, because the 8 is 2 root 2. A squared, you can pull an a out. B can't go anywhere. So now we have like terms. Root of 2ab, sorry, the root of 2b. Also, like out front, if this was 5b minus 2a, now you can't collect them anymore because those variables. But these two are identical. So 3a root 2b. Important note though, like if it was 2ab or this one was 2 squared, this is just 5a. They're not like terms anymore. Need to be identical. Like all the variables, the radicals, all needs to be identical. All right, ready for C? Is this enough room? Let me look at C. No. Oh my word. I didn't even look at my screen there. Was that visible the whole time? You guys catch all that? I didn't even look. Didn't even look. There's downsides to being absent-minded, and there are all of them. C. Cube root 27p cubed, 27p cubed, cube, plus 8 times cube root of p cubed 3. P cubed Q, P cubed 3. Okay, odd powers, odd indexes. That means that P and Q can equal anything. P and Q are element of the reals. So now we just have to simplify. This P is going to come out, right, because it's cubed. This P is going to come out. The Q's are going to stay behind. Is there no numbers in there? I read that down, right? Yeah, I guess I did. Okay, so 27 is 3 times 9, which is 3 times 3. The cube root of 27 is 3. There's nothing left over. 3 is going to come out. So 3, and then that P comes out. We're left with cube root of Q. Plus 8. That's just sitting there already. There's no numbers in here to bring out. Cube root of P is P. Cube root of Q. 3P and 8P. Cube root Q. Cube root Q. It's a tongue twister. You can add that all up. 11P. Cube root Q. That is your final answer. Oh, it didn't take up as much space as I thought. So now for our last check your understanding, it's mixing it up a bit so you won't always have like terms. That's what the practice is going to be here. Number 3, CYU, page 113. A says the 7 root m plus 2 root n plus 5 root n minus 3 root m. And it tells us m and n are both positive. Okay, so like terms, root of m, those ones go together. Okay, I don't have a green marker, a green pen. N, it's a root of n, nothing else in there. Collect the green, collect the red. So 7 root m minus 3 root m is 4 root m. 2 plus 5, 7 root m. Pause it for 1 second. Okay, so that's it. 4m plus 4 root m plus 7 root n. Okay. The next one. All right, I think I got room here. So for B, you've got 2 cube root negative 3b plus 8 root negative 3b minus 9 cube root. So pay attention because notice there's cube, single, cube, I guess it's square. Cube root negative 3b. I'm going to fit the next one. Plus 3 root negative 3b. Okay, so do you remember when I was saying that the whole radical, the entire thing has to be the same, including the index. This is a cube root negative 3b, cube root negative 3b. Those are like terms. They aren't like terms with these guys. Those guys are just square root negative 3b. Now we're told in the question not to cause, I guess, too much consternation that b is less than or equal to 0. So if b is not 0, it's negative, so we won't have any issues in the square roots or anything. So negative 3b and cube root, so this is 2 minus 9. Right? Reds go together. Negative 7 cube root negative 3b. We can't simplify that any further. We can't take anything out. And then 8 and 3 plus 11, just square root negative 3b. That's it. I would probably write this as a final answer in reverse just because I like leading with the positive, but it's not wrong. Okay, One more example, and I'm done blabbing. Three C says right here, because I feel like I'm running around. 3 square root 32a to the 5. Fancy. 32a to the 5 minus 2 root 45b cubed, 45b cubed plus 5b times the root of 125b minus 2a, I'm dodging this hole, that's why I'm angling down, root 72a cubed, 72a cubed, and it's telling us a and b are positive. All right, so this one here, this one requires a few steps. You got to simplify first and then see, you know, where your like terms are. Because as it sits right now, we don't have a single like term, but we might. These, the a's here, will simplify down to just a1. Both of these b's will just be b to the 1 when we're done with them. And I'm wondering how to show this to you. Because I want to do it on a separate page because it's going to become a mess on here. But I'm not. I'm just going to do it here. Hopefully it makes sense. 3. This 3 is going to multiply whatever comes out, hey? So let's say, okay, I'll just start with 32. 32 is 2 times 16, 2 times 8, 2 times 4, 2 times 2. 2 times 2 is 4, is 8, 16 is 32. This is square root, so we're going to take them out in pairs. So it's going to be 2 times 2, so that's 4 root 2. Square root of 32 is 4 root 2. But there's a 3 on the outside, so we've got to multiply that. 4 times 3 is 12. Root 2 is staying in, but what about those a's? A times A times A times A times A times A. Take out the pairs, so you've got 1a, so that's a squared. I didn't leave room on the outside. 12a squared root 2a. Okay, 1a is left inside, 2 is left inside. So this equals this. This is what I was talking about doing on a separate piece of paper. Where in the world do I go from here? Right? Well, let's just go down for now. No, I'm going to fill up the space. So I'm going to do the negative 2 blop, blop, blip, blop over here. So 45 is 5 times 9, 3 times 3. So the 3 is what's coming out. And it has to multiply that negative 2. Okay? So this here is negative 6, 3 times 2, negative 6. And then that b times b times b, you take a square out, right? So 1b comes out, 1b stays in. B comes out, the 5 stayed in, so the b's not alone. So this work is there. Maybe I'll do this one and this one in red, just so they're their own kind of animal. So we've got 5b. I have to collect all this at the end, hey. 5b times the root of 125b. That b is on its own. That b is not going anywhere. Sorry, b, you're stuck. You're a lifer in that sign. 125 is 5 root 5. Remember? 5 times 5 times 5 is 125. 5 times 5 is 25. 5 of those, 5 quarters, $1.25. So we take out a 5. So that 5 multiplies that 5, so that's 25b. Nothing changes with the b's. 1 5 stays in. This is equal to this. These things equal each other. All right. Now, so here's our, maybe I'll circle them in a different color yet. Oh, I have black, I think. Yeah, I need a different color marker. I'll probably got one somewhere. So we need this. We need this. We need this. Now one more to go. One more to go. And that is this one, which is a little busy. Negative 2a square root of 72a cubed. See right away, an a is going to be left behind. But let's deal with 72. 72 is 2 times 36, 2 times 18, 2 times 9, 3 times 3. We have a pair of 2's and a pair of 3's. Can you see that? A pair of 2's and a pair of 3's. So a 2 comes out and a 3 comes out. 2 times 3 is 6. 6 times 2 is 12. So this is negative 12. 2 is staying in, and one of the a's is staying in. A squared, the root of a squared is a, so this outside, negative 12a squared. And then what I say stays inside, the 2 and an a. Cool, cool, cool. So now, to summarize, let's add them all up. I'll circle this one too, just so it doesn't feel left out. So we have 12a squared root 2a plus 25b root 5b. Oh, I'm looking at this. Negative 6b minus 6b root 5b. Yeah, I went out of order. Doesn't really matter. Just get them all. Minus and then minus 12a squared root 2a. Well, look right here. Okay, so this is what it all equals. Okay, these were our 4 circled things. 1, 2, 3, 4. As long as you keep the sign, doesn't matter the order you put them in. 12a squared minus 12a squared. Those guys cancel completely. You got 0 root 2a. 25b minus 6b. 19b root 5b. These are both root 2a with a squareds. These ones completely like terms. Same idea here. It's a b on the outside, root 5b. b on the outside, root 5b. You can collect like terms. This is your final answer. Minor miracle. Fit it all into one page, but that was 33 minutes of examples. I'm going to say, because I think it got a little light last week, I'm going to say this is still all due. Okay, 3 to 10. Lots of you probably go through it pretty quick. Let me know, anybody, if you get stuck at all. If it's too difficult or whatever. And see what tomorrow holds. Multiplying and dividing. Oh, that's, I think, a bit easier. So, kind of like multiplying and dividing fractions. Easier than adding and subtracting. All right, my friends. That's it for today.